Hello and welcome back to the Inside Java podcast, a podcast that discusses everything Java brought to you directly by the team at Oracle that builds Java. My name is David Delabassee. This is the second episode out of a conversation I had with Maurizio Cimadamore and Jorn Vernee about Project Panama. In the previous episode, we discussed Project Panama and the Foreign Memory Access API. In this episode, episode 10, we continue that discussion by zooming on the Foreign Linker API. So let's now discuss the second API of Panama Foreign Function Support, and that is the Foreign Linker API. Can we start with the key design goal of that API?
So the key design goal basically is to enable calling native functions, and when we say native, we're talking about code that is written in the platform's own machine code, in the platform's ABI, to be able to call that from Java.
And it's both ways, right? Down call, so Java calling native code, but also up calls, so native code calling Java.
Yes, that's right. In the C language, it's possible to call functions through a pointer. So we also have ways to wrap Java methods in these function pointers. You can pass a pointer to a C function, and the C function can then, through that pointer, call a Java method.
Another main goal of this API is essentially to free some of the burden that developers have to bear about writing native code that is attached to their native methods. So we have seen before how writing JNI code always involves writing some form of shared library or native code. And this code can go off sync with the foreign library that you are targeting, so you have to regenerate it all the time. So it's yet another place where things can go wrong. So by removing this interaction, we can actually target directly the foreign library, and we can probably make it easier for people to distribute libraries that are based on foreign libraries and remove the chances for mistakes.
Indeed, that's something important to mention. So can we now discuss the key abstraction of the Foreign Linker API?
Yeah, the key abstraction is probably the linker, hence the name of the Foreign Linker API, which is basically an API where you can ask for a native method handle that will allow you to call a native function. You provide it with a Java method type, which is basically a description of the Java side of the call, and then with a function descriptor, which is the native side of the call, and then the function address, which you look up with a library lookup. And then the linker will generate code. It's basically a mini compiler underneath that will generate code to go from the Java world to the native world, and then return a method handle which encapsulates that.
Basically, the mechanism that Jorn described, so we have to pass the Java signature that is to be attached to the native method handle that is going to be produced by the linker, and also a description of the signature of the C function that we want to call. And this is done by using a bunch of layouts. Is a very general mechanism that allows the runtime to basically infer some kind of recipe that allows the runtime to basically move all the Java arguments in the right positions. So if you're passing Java values, the runtime will know exactly what to do with those values. So in which register to store them or in which stack slot to put them so that the native function call can actually take place correctly. So it's a very powerful concept that allows us to infer quite a lot of information just by providing very few details about the foreign function.
Mm-hmm. Now, concretely, I want to do a down call, so my Java code needs to invoke a native function. What should I do? What are the steps?
You first get a library lookup. So currently for JNI, we have the system.load library API and the system.load API that allow you to load a native library such as a DLL or .so file on Linux. And then from that, using the new library lookup API that we add to the linker API, you can load a library and then look up a function address given a name. That gives you an address, and then you give that to the C linker API together with a Java method type and a function descriptor, and that will then return a method handle to you that you can use to call that native function.
And what about up calls?
Yeah, so if you want to invoke a Java method from native code, you have to first get a method handle that points at your Java method, and then together with, again, a function descriptor that describes the native part of that call, you can pass it to the other API that's found in SeedLinker to get an upcall stub, and that basically will, again, generate a bit of code to go from the native function descriptor to the type of the method handle that you passed it, and it will return you basically a function pointer that you can then pass to a native library, and the native library can call that function through the pointer, and then it will go up into your Java method.
Okay, now back to down calls. So Java invoking native. You mentioned that the initial step was to get a library lookup. And I vaguely remember some GNI class loader limitation when it comes to library loading. So are we facing similar challenges with the foreign linker API?
So the issue with JNI in particular is that you cannot load a native library from multiple class loaders. So if you load a native library through system.loadLibrary, it will be tied to a particular class loader. And this is basically a security feature that prevents loading the same native library in two different class loaders. On one side, passing a Java object with a particular name into the native library. The native library stores it somewhere in a global constant or global field. And then from the other class loader, you load that object back again. The classes have the same name, so everything works out. But actually, the actual class underneath is different. So it allows you to spoof a class. And basically, this is a security concern. So in JNI, this is solved by saying, if you load a native library, it's tied to a class loader, and you can only use it from that particular class loader. But because in Panama with the foreign linker API, we do not allow passing Java objects to native code, at least not directly, this spoofing problem does not exist. So we don't have that limitation in the foreign linker API.
This is a good segue to discuss the potential safety challenges that we might have with native code.
Yes, it's very challenging because typically, I guess, when these native library formats were designed like decades ago, in the infancy of computers, there was more of an emphasis on being as efficient as possible. You had a lot more memory disk constraints. So there's not a lot of extra metadata found in these libraries. For instance, there's no metadata on what kind of ABI the functions are exported with. This is all found separately in header files. There's nothing like type information. Basically, a native library is just a name of a table of names and pointers that point to code somewhere in the native library. So there's not that much in terms of safety we can provide. Basically, we just have to trust the developer that the method type, the Java method type, and the native function descriptor they provide actually match what is found in the native library. Though there are some experiments that we could try. For instance, we could try looking at the debug information found in native libraries to try and verify some of the things that we get from the developer. But that is an experiment for the future. We haven't done that yet.
There is also another aspect to safety, which is more implicit. Like one is what Jorn described very well, which is like the signature information is just not there. So there's nothing we can validate against. The second is that even if we add signature information, if you look at a lot of C APIs, well, they are not really written in a way that is kind of safe in an explicit way. Like some API take maybe a pointer, and maybe there is a separate argument that defines what is the size of the memory that is behind that particular pointer. So there is no constraint in the signature itself of the API of the fact that the pointer is going to be n bytes long, 12 or 42. So it's basically all up to some contract which is defined in the documentation of the API. And as such, there's very little that we can do in order to enforce these kind of things. So these are all constraints that can be enforced downstream by the programmer that wants to expose one of those native method handles as an API to somebody else. So that's where you have an opportunity to add some of these extra domain-dependent checks. But in terms of what the linker API can do, that's not a problem that we can solve.
Mhm. So can we close the safety discussion by quickly explaining restricted methods?
So for safety, one of the things that we had to do for the foreign linker API was to basically demarcate which methods in the API were safe and which methods weren't. So there are some methods in the API that you will see are marked as restricted. That means that even though they are part of the Javassee API, you have to have an extra flag on the command line in order to be able to call those methods. So you basically should give trust to the runtime environment in order to be able to access those methods in the first place. Right now, this is done by using a JDK runtime property. So this is a shortcut that we took while the API is still incubating. We are exploring some option to have a better mechanism that doubles down on the module system so that you will be able to grant native access to specific module in your application. And that is how we will plan to make safe and unsafe API coexist in the Javassee ecosystem.
Yeah, makes sense. So after safety, I'd like to quickly tackle performance. So can we somehow contrast and compare the performance with JNI against the performance when using the new Panama API?
Yes, so it turns out that especially for down calls, JNI is already pretty optimized, and it's more up to what kind of programming patterns developers use when they use JNI that causes slowdowns. In particular, for instance, if you're doing a JNI call just to access a single memory location in a struct, for instance, you have a point struct, you do a JNI call just to get the X coordinate from that point. That adds up, especially if you do that a lot in a loop, because the native call is opaque to the Java JIT compiler. So it can do things like loop unrolling, it can do things like eliminate checks, and it can do things like auto vectorization for those kinds of accesses. So in those cases, the off-heap memory access API, the foreign memory access API, acts to make that a lot faster. If you're using the JNI API very excessively in your native code to access object field, Java object field, this is also pretty slow because every time it has to do transition into the VM, it does a bunch of bookkeeping, it retrieves the Java object, and then you go back to your native code. This is also not very fast, and up calls in general are not very fast. But by moving most of this to the Java side, it becomes fast again. Maurizio coined the term, we call this the Panama effect, of moving more things into the Java side. They become more transparent to the Java JIT compiler. It can be optimized in combination with the surrounding Java code. And that is actually what gives most of the speed up in the case of foreign calls.
Let's move on as the clock is ticking. So I did some experiment with the Panama API. The method handle API and the variable API are used a lot. They are leveraged nicely, which is good. But the problem is that those API are also quite low level. So can we discuss a little bit the tooling angle of Panama?
Basically, as you say, the variable API and the method handle API are kind of pretty low level tools for Java developers. They are very powerful, they are very efficient, but they are also very hard to use and it's easy to make mistakes with those tools. For this reason, it's very unfeasible to propose to use these tools for porting entire native libraries just using variables and method handles. It would be very tedious for the developer to define, for example, a variable for every struct, for every field in the struct used in a native library, or a method handle for every function defined by the native library. For this reason, we think that tooling still have a big role to play in this story that Panama wants to be able to play. And we think that a tool such as JStract, which is able to digest all this information about existing header files and automatically spit all the variables and method handle definitions that are required in order to basically define the plumbing that are required to make this API work, still play a very crucial role for the usability of the Panama story. Unfortunately, we couldn't make JStract available as part of Javassee 16. We are still working on polishing a little bit of the JStract tool, We want to make it more configurable because there are things that maybe developer will want to inject or they will want to be a little bit more opinionated about the output that comes out of JExtract. But for now, I think the tool is available in an early access build, and it can be used against the foreign linker API that is going to come out in 16.
That's a good point. So the foreign memory API is in its third incubation in JDK 16, while the foreign linker API incubates for the first time in 16. So JDK 16 will be released in March, and in the meantime, we can already use those API using a JDK 16 early access build. But for JExtract, we have to either use the Panama early access build or build JExtract and use it on top of a JDK 16 build. Is that correct?
Yes. All the APIs are compatible with each other, so it's not like using JExtract is not going to work with some of the APIs that are introduced in 16, but the tool is just not included in Java 16. So you will have to go through the Panama early access build in order just to get to the tool. Then the tool will generate some output that is fully compatible with Java 16, so you can take it from there.
Mm-hmm. Now, can we quickly go over the platforms that Panama will support?
Yeah, so the supported platform currently are basically, it depends on what kind of ABI these platforms use underneath. So currently we support 3 ABIs. We support the Windows 64-bit API. We have the sysv 64-bit API, which gives us access to use foreign functions on Mac and Linux. And then we have the AR64 ABI. We support those 3 basically, which gives us access to the platforms Windows 64-bit, Mac 64-bit, Linux 64-bit, and AR64, which is also the platforms that Oracle support.
Okay. We had a very good discussion on Panama foreign function support, but time is running. So I would like to ask one final question on Panama. So the next major milestone for the project is Java 16, JDK 16, that will be released in March 2021. So how do you see things going forward after that?
I think most of the future work that is visible in the API will go into JExtract. I think at least I have a lot of plans for streamlining the implementation of the foreign linker API and maybe experimenting, as I said before, with reflection of native libraries. So being able to look at more of the metadata in native libraries, such as debugging simples. Another interesting thing I was thinking of exploring was support for native Stacktrace elements. So, for instance, if you're in Java, you call into a native function that does an opcall into Java and there's a crash there, then the Stacktrace will just say Java, 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 native code, which is all opaque, and then go back to Java, Java, Java. I think it might be interesting to experiment with actually putting something more informative there for the native code. Which could also help, for instance, if there's a crash in VM code, which can happen right nowadays. The VM is more and more relying on Java code to do some of the VM internal stuff, for instance, in Java lang invoke. If you link an invoke dynamic instruction, it will first call into the VM and then call back into Java. If there's a crash in the Java code, then the stack trace will look very weird. It will start in the code in Java lang invoke and then suddenly jump to the user's Java code that has the invoke dynamic instruction, and there's nothing in between, and you're looking at this, well, I'm not calling this VM internal code from this line, so what's happening here? And maybe it could help if you have like an experimental option for showing more of the VM frames there as well.
Maurizio?
I guess in general, a lot of effort will need to be put in those topics that Jorn covered about kind of improving diagnosability for issues. So we need to do better both on the memory access API. For example, you may want to have some kind of leak finder, things that help you detecting native memory leak when they occur. Netty has something like that, and maybe we can explore doing something similar. And on the foreign function support, currently, the JVM provides some diagnostic support for JNI calls. It's called JNI check option. And that provides some useful hint when you're calling a native function. For example, you're passing a null. And in that case, the VM will tell you, well, beware, you just pass a null for this argument and maybe there could be a problem there. I think we can do more of this heuristic. I know other languages such as Python as a library C types that does some of this heuristic in order to detect whether you are trying to call a native function with the wrong arity, so by providing the wrong number of arguments. I think it would be very nice to see some more effort to be put into making sure that when things fail, the user has at least some idea of why things have failed and what it can be done in order to make things better. Another thing that we need to invest a little bit more, and that kind of needs to wait a little bit for other language features to come, is how can we use, for example, things like Project Valhalla? So can we use primitive classes in order to define linear wrappers around, for example, native structs, or to define a pointer API that doesn't cost too much for developers to use. It doesn't introduce too much allocation, or it retains the same fast memory access characteristic as the memory access API. Can we use operator overloading to maybe mimic some of the access that currently has to be done with Varendo? So there's a lot of string to pull when it comes to some of the areas that are currently being under exploration in Project Valhalla. And I think there is a nice synergy between both Panama and Valhalla, and also between the Panama foreign side and the Panama vector side of things, because now that we have both of the APIs in Java C16, people have already started asking whether we can have, for example, a way to build a vector out of a memory segment. So you will see more of this interoperation going forward.
About observability, are you thinking about GFR, for example?
Yes, JFR is also another thing that needs to be on that list. Yes, definitely. Maybe having custom events for native code and things like that.
Well, we have to conclude. But before, is there anything you would like to add? Maybe a call to action?
Well, I can only reiterate my plea to go either on the JDK mainline repository, try to build it and play with it, or download an early access build for Panama, try your own favorite native library, and let us know on the Panama dev mailing list what you think, if you think that the tools are good for the example that you tried, which obstacle did you find. Feedback like this is very important to us to come up with the right design for these APIs, because it's not trivial to design things like this.
Okay, one final question to end. This show is called Inside Java. Can you give our listeners a peek inside your day? Maurizio, you start?
Well, I wake up and then I turn on Slack and then I see what crashed overnight or what needs to be fixed. And that kind of keeps going on. At least over the last few months, it's been like that. No, seriously, especially during this very difficult and challenging period for every of us, I think it's been great to be able to work with people like Jorn and others on the Panama team, and having this kind of regular chat with somebody has really helped me going through this particularly stressful period. And then, of course, during the night, I like to chill out a little bit, maybe playing Xbox game. I'm still waiting for the newer Xbox to be available, by the way, but that's a separate story.
You should get a PS5.
Yeah, maybe.
Okay, thank you. Jorn, what about you?
Pretty similar for me. I wake up and I turn on Slack and then see what kind of messages came in from my colleagues while I was asleep. But lately I've been more focused on getting the API finished, and there's a lot of platforms to support in the JDK. Even spent a lot of time trying to help the downstream port maintainers with, for instance, the 32-bit port. But programming and coding like this and working on these cutting-edge implementations with an amazing team at Oracle is definitely the highlight of my day. But outside of that, I enjoy hiking quite a lot. And then I also play video games. My main favorite is playing O's. Last time I looked, I was number 8 of the Netherlands, so I'm pretty good at that.
Okay, cool. Well, Maurizio, Jorn, thanks for your time. It was really a nice conversation. Thanks.
Thank you, David.
Bye.